Hey everyone, it's Mrs. Slauson. So last week you should have watched a video that kind of was a little intro to inequalities, which actually it shouldn't have been an introduction because it's something that you saw in middle school. And today what we're going to do is talk about solving inequalities. So we've been practicing solving equations, and now we're going to do, excuse me, solving inequalities. So the steps are going to be pretty much the same. It's just, what does it mean that in your answer, how is it different than solving an equation? So just a quick reminder, we've got our less than, our greater than, our less than or equal to, and our greater than or equal to. I remember that this is less than because it looks more like, let me find a color here, like the letter L than the other one. All right, and then the other reminder is when we write our answer, we want to write our answer regardless of the variable that we're solving for. I think it's going to be x a lot. We want x first, and then we want whatever inequality sign it's going to be, and then our solution that we got when we solved. Okay, so going through solving, I'm going to treat these as my equations. I'm solving because I have to isolate x, and when you isolate x, we are working backwards in the order of operations after we do our prep work. Our goal is to get these problems into two steps. So first I always look for parentheses. I don't have any. I do over here. I look for combining like terms. Nothing to combine here. There's nothing to combine over here. And then I look to get x on one side, and it already is. So what I'm going to do is just take my two steps. I'm going to move my addition, subtraction, and then I'm going to get rid of my multiplication, division. So to get rid of the 5, I'm going to subtract 5. So some people, I need to find a pencil here. Some people might say, you know what, why don't we add 5 because of that subtraction sign behind. So just to show you real quick again, I think I showed you this before. The reason we don't add 5 is because if I have 5 and I add 5, I've actually made this bigger and I haven't gotten rid of it. And again, our goal is to get rid of everything that's hanging out over with x. We got to isolate it. So I'm going to subtract 5, and I'm going to subtract 5, and this cancels out, and this subtracting 2x becomes a negative 2x. And then over here I have a negative 2. And then I'm going to undo my multiplication and division. The negative 2 is multiplied, so I'm going to undo it with division. Those cancel out. Come over here, and those cancel out. So the x is now isolated. Negative 2 divided by negative 2 is 1. And hopefully you remember from middle school that in an inequality, if you multiply or divide by a negative number, you have to switch the inequality sign around. And I guess the basic explanation is because this number went from a negative to a positive, and when it makes that drastic of a change, for lack of better words, everything changes. This changes, and the x as well, that stays the same. So instead of less than or equal to, I lost the equal to, I'm going to switch it to greater than or equal to. Okay? Finishing this up, we'll actually do the next one. So my first step of prep work, I see parentheses, so I distribute. I'm going to go ahead and draw my wall. So I have 3x take away 6. I look to combine like terms, no. Combine like terms, no. Get x on one side, it already is, so I'm ready to do my two steps. So the first thing I'll do is undo the addition, subtraction. They subtracted 6, so I'm going to add 6. Get 1, and, or I'm sorry, not 1, 11. And now to get x alone, I will move the 3, and since they multiplied, I'll divide. And when I'm done, I have x, I have less than, and I'll keep this as 11/3. If you have a calculator, you could always take 11 and divide it by 3 and get that decimal value. And that should be 3 point, and then a bunch of 6's repeating, so, I'll just round that decimal up. Okay? All right, so the other thing that we talked about in that last video is how do I graph the solution set on a number line. So remember, you're going to use the closed dot if it's the equal to ones, and you're going to use the open dot if it's just the less than or greater than. So let's just take these answers up here and put them down here. So recall, again, I like to have my reference point of 0, and then I like to put my answer in comparison of it. and because 1 is bigger than 0, it goes to the right. And then you can either, draw this on the number line. Sometimes I put it above the number line. I do a little bit of both. So I'm going to go ahead and put this above the number line. So x is greater than or equal to, so I'll have to make a closed circle for the equal to part. And again, this is saying that all the answers are going to be bigger than or equal to 1. So bigger than 1 on a number line goes to the right. But remember, if you always keep x on the left, then the inequality sign, and then the number, whichever way this points, it's pointing to the right, is the way this will point. So it's almost like I'm taking this symbol and putting it right here. Okay? All right, on this one, so I'm going to do my reference point of 0, 11/3. Again, 11/3 is technically the better answer. Again, it's about 3.67. Since this is just less than, I'll do a closed circle, and then less than. So this is saying all the answers would have to be smaller than 11/3. So smaller would be to the left of 11/3. And again, since x is on the left, then since this points to the left, I can have this point to the left. So let's try a few word problems. Some of them are a bit of a challenge, but that's okay. We're always up for them. All right, so if 5 times a number, yeah, you can see that, is increased by 4, the result is at least 19. And so we're going to talk about this at least, because that at least people think less than. So first we're just going to write this out. 5 times a number, so 5 times some number, is increased by 4. So we're going to add 4. The result is at least 19. So maybe in the last chapter we would have said the result is 19. So is 19, I would have had equals 19. So for now I'm not going to put anything there. Let's talk about what at least means. So if we put this, I'm sure you've all been to some type of carnival, Elitch's, whatever's downtown, and you go and you look at the ride and it says, you must be at least 4 feet tall to ride this ride. That means you must be at least 4 feet or bigger than 4 feet. So I think people hear at least and they think less than, but actually means that you have to be greater than the 4 feet. So that means that this, whatever I do over here, has to be at least 19, if not more than 19. So that means more than 19 will go like this. And at least 19 means I can include 19, so I'll underline it. And now we're going to solve. So again, looking for those my prep work, no parentheses, can't combine like terms, can't combine like terms, x is already on one side, so I'm ready to do my 2 steps. First I move, here's my wall, I move the addition subtraction, they add 4, so I'll subtract 4, canceling out. I get 15, there's my little underline. And now I'll undo my multiplication division. Since these are multiplied, that is an x. I'll undo it through division, so you can't see it, but imagine I'm writing divide by 5 over here. I'll divide by 5. It would cancel out. I ran out of room. And then x is greater than or equal to 3. So basically, numbers that would work for this solution are 3 and anything bigger than 3. Okay? So let's just test that out. Okay? Because hint hint, this might show up on a quiz somewhere. So, something that's bigger than 3. Well, 5 is bigger than 3. So, if I pick 5, it should make this inequality work. So, here goes. I'm going to put 5 in for x. I just picked some number bigger than 3. And when I'm done with my order of operations over here, again, this is just evaluating. When you see a bunch of numbers, follow the order of operations. We're going to see if this inequality is true. And it should be true. So first I multiply, that's 25. 25 plus 4. When I add those, I get 29. And sure enough, that is a solution that works. So I could pick 3, I could pick 4, 5, 6, 7, 8. I got a lot of choices. All right, let's keep going on. A little bit on the back. So just a few more word problems. So the velocity of an object is modeled by, here's the equation, where t is the time in seconds, And for this model, time is non-negative, which is saying time is positive. We can't have negative time. So that's just a reminder. And we're going to find when the velocity is less than this 43. So first of all, let me grab a pencil. I'm going to rewrite this so that the v is over on this side. I think that's what I want to do. Okay? So remember, this is the velocity, right? So what they're saying is that this velocity, 2t plus 15, needs to be smaller than 43 meters, okay? So this has to be smaller, less than 43 meters. So I hope that made sense. This is kind of a tough one when you do inequalities with word problems. So again, I'm ready to solve. We're going to write our answer as an inequality. So I draw my line, I look for my prep work, no parentheses, no combining of like terms here or here, and x is already on one side. So 2 steps now. We are going to move our subtraction, subtract. I'm running out of room, so let me put this over here. I need to write smaller, huh? And 43 take away 15 is 18. And then now I'll undo my multiplication and division. So these are multiplied. I'll use division to undo that. Remember, those are just inverse operations. And when we're done, our time is less, that's 9. So remember, this says that time is non-negative. So time has to be positive. And the way I'm showing this right now is this would be anything less than 9, which, 3 is less than 9, but so is -3. So we want to make sure that we say that this is non-negative. So what I'm going to do is throw this in here. And I did mention in that other video, kind of that basics of inequality, that this is in between. When you have the variable with 2 less than signs, and it can be underlined as well, but they are less than signs, that means between. So the time has to be between 0 and 9. Because anything smaller than 0, that's a negative number, and time can't be negative. All right, let's go through this. Heads up, we're going to hear the bell ring on this one. So just let you know. All right, the total price of taxi fare can be modeled by this equation, where P is the price in dollars and X is the number of miles driven. So how many miles can you travel to keep the cost, so the price, less than $50? So remember, this, and I'll keep it on this side, right? This is the price. We want this price, this cost, so I'm going to rewrite it over here. I want that cost, that price, again, to be less than or equal to $50. And now we're ready to solve. So, let me draw my wall. Again, I look for that prep work, no parentheses, no combining like terms, and x is on one side, x is on one side. So, addition, subtraction, let's write that over here. I'm going to subtract 10, that cancels out. Here I have 40, and then I'll undo my multiplication division. So these are multiplied, I'll divide, cancels out, and when I'm done, I have x is less than or equal to 20. So how many miles can you travel to keep the cost less than or equal to $50? So right now this is saying I can travel 20 miles or I have to travel under 20 miles. And even though they don't mention it, I'm going to do this in between thing again because my miles, I can't have negative miles. So remember, this is between, so my mileage needs to be between 20 and 0 because I'm not going to have -1 mile. So there was the bell. Let's see, I think I'm going to pause here. I will pick this back up and then we'll be done with this video.